Alright, this week we're going to be looking at mean again and mean absolute deviation. We hope to, by the end of the week, calculate the difference between two means as multiples of the mean absolute deviation. So first, let's look at mean. What does it mean to find the mean, MEAN? And that is when we find the sum of all numbers in the data set. So we're going to add up all the numbers. If you didn't know, this is a dot plot, and every dot on here represents the number that it is above. So for instance, we have 1, 2, 3, 4 tens, and then we have 1, 2, 3, 4 nines, and we're going to add them up. We should know off the top of our head 4 tens gives us 40, and we have 4 nines, 9, 18, 27, 36, and we're not done yet. So now that we have all our numbers in the data set added up, we need to divide by the amount of items in the data. So we count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different numbers in this data set because of the 8 basketballs that we have there. So we're going to divide this number by 8. And that gives us 9.5. And awesome. Now we know that the mean of this data set is 9.5. We can go ahead and mark this spot on our board. Let's use a red line. Awesome. So our mean is 9.5. Let's go ahead and mark that on our dot plot. And we have about 9.5, halfway from 9 and 10. So we have our mean in red. It is at 9.5. And now we know that mean is useful when you want to summarize the whole data set. So if we wanted to quickly summarize, about 9.5 baskets scored per game. So where Terry's playing basketball. And now we look at the word as a whole, mean absolute deviation, and that is when we look at the average of how far each point is from the median of the entire data set. So we want to know how far each and every point is away from the median. So we're going to take each number, 9, and subtract the mean. So 9 minus 9.5 will give us 0.5. Then we keep going. Another 9 minus 9.5. It's going to give us 0.5. Awesome. Then we do the same thing with our tens. We're going to have 10 minus 9.5. That equals 0.5. And now we're going to add up all the totals, 0.5 plus 0.5 plus 0.5, and so on, all the way up until we get 4. So we have 4, and we're going to divide that by the amount of numbers, and we found out it was 8. Awesome. And now we know that the mean absolute deviation is 0.5. Awesome. So we're looking at our dot plot, and we're looking at the information that we now know. The mean is 9.5. The MAD, or the mean absolute deviation, is 0.5. And now we're going to do the same thing for Chris. Chris's baskets scored per game, and we're going to calculate first the median by counting. Remember, each point on the dot plot represents the number below. So we have 2 plus 5 plus 8 plus 8 plus 11 plus 13 plus 14 plus 15. And that gives us I'll wait. Grab your calculator and try it with me. Once again, you're adding up all of the balls that we have here, or points on our dot plot, and we find out that it gives us 76. So we know that is 76, and we're going to divide that number by the total amount of points in our data set. And we count. We have 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Divided by 8. And look at that. We have the same mean. The same mean. We don't know what the mean absolute deviation is just yet, but we will calculate it. First, let's put the mean on the graph here. 9.5 once again is just about there. And now we'll find our mean absolute deviation. We want to know how many spaces away is this ball from the mean. We're going to count all the way over. Or we can take 2 and subtract 9.5. Now we'll see that if we type that in the calculator just like that, it's going to actually give you a negative. And that brings in the word absolute. Absolute value of any number is the distance it is away from 0, or in this case, the distance away from 9.5. So we're actually going to assume whatever number comes out on our calculator is going to be positive. So 2 minus 9.5 would give us 7.5. We have 5 minus 9.5, and that's going to give us 4.5. We're going to keep going. 8 minus 9.5, that'll give us 1.5. We have 2 of those. And that's 1.5. We have 11 minus 9.5. And that gives us 2.5. Nope, it gives us 1.5 because we want it to be a full 11. And then we have 13 minus 9.5. And that's going to give us 3.5. And we have 14 minus 9.5. That'll give us 4.5. And 15 minus 9.5. And that'll give us 5.5. We now need to add up all of the numbers here all the way down. So 7.5 plus 4.5 plus 1.5 plus 1.5 plus 1.5 plus 3.5 plus 4.5 and then plus 5.5. I'll give you a moment to figure it out and then we'll do it together. Which gives us 30. And we're going to divide that by the total amount. We're going to divide that by the total amount of numbers all the way up. So we have 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8. And that gives us 3.75. So let me erase that really quickly. Our mad here is 3.75. So just as a quick review, so how do we calculate the mad? Step 1, find the mean. You want to add up all your numbers in your data set. You want to divide by the total amount of actual numbers. So you'll add them up and then you'll count how many numbers are actually there. Step 2, find each absolute distance from the mean. This does not include negative numbers. We want to find out the distance from the number to its mean. So where the mean is in the data set. Step 3, find the mean average of those distances. So we're going to add up the amount of spaces over it is from the mean. So here we have 1 plus 1 plus 0, 0, 0, 0. Why? Because this was exactly on the mean. Plus 1 plus 1. And it gave them 4 altogether. And now we're going to divide by the total amount of numbers on the dotted line. And we have 8 altogether divided by 8. This would give us a MAD of 0.5, which means that the numbers are pretty close together.